to like you include a view, but it is going to be like just coding your UI instead of writing out everything in XML and then find view by ID and change its state. So the prerequisite is you have experience with Kotlin and also lambdas, because Compose uses lambda heavily, and we'll just go through it. Also, the minimum requirement is you have Arctic-Fox, which is now stable. So I would encourage you to upgrade. Yeah. So we will start by creating a new Compose project. For this, I think we'll just follow it on the webpage. In Arctic-Fox, when you create a new project, you will see this new empty Compose activity, and then you can just like click next, and you will just create a new activity, and then you will end up in a UI. So it just goes through like what you should expect when you create a new empty one. And I'm going to say continue on the web page, and here are the dependencies that you want to include. And somehow it says we need to remove Kotlin compiler version. Oh, because we actually need to use a Kotlin compiler extension. Compose relies on this extra Kotlin compiler extension to do its magic. So we'll need to do that. And this will be what's in the generated code. I think what we need to specify is if you check out this this GitHub URL, you are actually going to see the full solution that will be like what we go through today, which is also fine. Yeah. So let me switch to show my Android Studio. Presenting Android Studio. So in theory, this is like the new project wizard, and this is the empty compose activity thing that I just selected. I'm going to say collab and it actually can support min SDK to even further, but I'm going to just say 23 and finish. So because Android Studio switched to a different window, that's why we got kicked out again. But let me share again. Sorry for the for screen jumping. And you see the main activity is like what is shown on the web page. And I'm going to just switch to project files and go to build.gradle. And so it says we need to remove this. Although when I did it first time, I actually forgot and it still worked. So I don't know, maybe it will just work. But now the Gradle is syncing and it's building and downloading stuff. And it will just be a bit of wait. And I'm going to switch to step 3 on the Collab. So it is getting started with compose. So what is a composable function? Composable function is a regular function annotated with composable. So it will basically say you can only call composable function from another composable function. And by marking things as composable, Android Studio will actually show you this split view. So once we refresh and let Gradle build, you will see something that's showing there. And we'll have to give it a bit of time. But if you are familiar with the existing tools, this looks like what we see when we edit the layout XML. But in this case, we're actually showing composable functions. So this thingy here is a preview of this composable function. So basically, it's saying in StudyJam, using a StudyJam 3 or this application's theme will show a view called greeting. And that's also what is here in the set content. So in a composable activity, you call set content, and set content will actually be able to call these composable functions. So this is a composable block. So Actually, I just went through the compose in Android app section somehow. So on the web page or in the Collab, it will say basics Collab theme. But in mine, because I created with the name StudyJam 3, so that's what you will see. So that's the difference between my Collab and like the thing on the web. But other than that, it should be pretty much the same. Um, so this theme is a way to style the composable function. And in a later step, there's a theming your app that is step 8 in this collab, and there we will change some of the properties, and you will see color change like you did in the old days, where in your theme file you can specify like background color and things like that. So now it also talks about the background preview. So we can say, for example, in the default preview, we can give it a name called text preview. Then once I save, it should change the right-hand side to show it to be text preview. So yeah, and that's what we see on screen. And we can just, if you want like less noise when you are editing Kotlin code, just switch to code only block. Otherwise, split works. Design, in my opinion, is kind of useless in like say viewing these previews, but maybe people will find it useful. I haven't, maybe because I'm not using this and doing my day job to appreciate it. So moving on to step 4, decorative UI. Say if you want to set a different background, so we can say in the greetings, in this greetings compose function, we'll just host the text in a surface. So surface is another composable function, and we'll say color yellow, and then we'll host it here, and we can say like we'll have a explicit import. So now it asks us to build and refresh. So I'll just hit Control-Shift-F5, and it should change the color to yellow. So basically, you modify code, and it's like reflected right away after you build. And what this does is introducing us to the concept of modifiers. So these compose classes, they have a lot of default parameters, which is not in Java, but in Kotlin. And the use of default parameters makes it possible that you can just say, I want a regular surface without specifying anything, and it still work. But if you are trying to do this in Java, then you'll probably like see you have to basically specify all these modifier shape, blah, 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 blah. So in Kotlin, because of the default parameters, we are able to basically say, we can just override color, and later we'll pass in a lot of modifiers, and that's all done because Kotlin has default parameters. So now what do we do? Oh, we want to actually add modifiers to the text to change how it appears. So we'll say modifier equals to dot padding. So we'll add 24 dp of padding, and we need to import the TP as well, and then refresh. So we should see a lot more padding. Yes, we do see a lot more padding. Hopefully that it is actually 24 dps. And so that's the modifier. So what does this mean? This means by using modifiers and using default parameters, we'll be able to say modify the view properties this way, instead of the old ways of creating a different style and apply it, and then also switching styles in the middle of runtime is also impossible. But with Compose, you can actually now do that. You can now do that easily. It was almost impossible. It was doable, but now it's more like you can, depending on the state, you can have different modifiers because it's all in code. So you can have conditionals and stuff like that. Next up is Compulsory Reusability. So the more components you add to the UI, the more levels of nesting you create, just like other functions in your code base. So it wants us to make small reusable components, and we should be able to reuse them easily. The node section allocate necessary just for functions which emit UI or call other composable functions. They can call both regular and other composable functions. So what you want to say actually annotate or compose is like things like greetings or surface or text itself, but like functions like in the main activity, you shouldn't annotate it with compose. I wonder what happens if I do this. It will probably throw an error at me. Yes. Yeah. So, um, so I did something stupid, and you see it's airing out. So you don't have to try. But let's see. So we want to refactor this. Basically, we are using these outside of the main activity. So these are top level functions in Kotlin, and they are actually globally visible. So you can actually call these from a different file other than main activity. But let's not get there. Let's just follow the collab. So they want us to create a composable myapp function to make this thing more reusable. So I'm just going to copy paste. So composable fun myapp. And because the theme is different, so I'm going to copy. Maybe I should really just name the collab as basic collab instead of StudyJam 3, but well, this will keep me honest. So basically it is defining the theme to contain a surface of yellow color and greetings. And that is what is in the set content, right? So we'll just call it from the set content block to become my app. And then our greetings should also be changed because now we already have the surface defined outside in the scene in this container, so we can take that out again, and then we want to change the default preview to just be my app. So the thing will look the same, but the organization is a bit different now. Let's see, set content. Did I mess something up? I have one extra closing bracket. So let me try again. So yeah, it looks the same because it is the same code. It is basically just moving what was in set content out into my app, and then we also call my app in the preview. So that's the first refactoring. Then it start to introduce the container function. What if you want to create a container that has all the common configuration of your app? So I suppose this container is like the base theme of your app, but we'll just continue. My app content add compose. So we want to add a parameter called content. It is actually taking a composable function. So this, or I should say this, open bracket, close bracket, and then an arrow, and then unit is a function definition in Kotlin. So this is basically saying you can pass in this content and the type is a function. So I can actually call my app with say fun foo and no return. Then I can call foo here, composable. So that way foo is actually of type a composable function, and that will be passed as content. So just a quick primer on Kotlin for those of you that are not that familiar with Kotlin. So in the node section, it says the extra parentheses. Oh, they are actually needed. So yeah, it is reminding like you actually need to specify this to signal to the compiler that this is a function that takes no parameters and return type is unit, which is void. So now I want us to say, like, instead of the surface here, we'll just call content. And then in the preview, we can say my app and call greetings and Android. So this should still produce the same output. And of course, I did not make the right call in both places. So the reason why I was removing the the parentheses is because in Kotlin, for the last parameters you pass in, you don't need to enclose it in the parentheses. So that's why you're seeing this, but it is actually the same as this. So let's run again. But you'll see lambda argument should be moved out of the parentheses. So it is syntactically the same, but it looks more Kotlin-y with by like moving it outside of the parentheses. So now we are passing this greetings composable function into my app as the actual content of the app itself. So yeah, it says it's more flexible because I can say, for example, I can create another composable function and say my fun and show nothing, but I can just say call with my fun there. Then it will probably be like an empty view with nothing because my function has nothing in it. But say if I just say, then it will just contain a yellow background containing a text of ABC. There you go. So yeah, it is more flexible. So you can pass in the content there. So the next one is now we'll actually start doing more like actually creating UI. So now we want to create a function called my screen content. So let me remove my function and then I'll just call my screen content there. Now we're looking at something new, a thing called column and divider. So which one should I use? I will just say the first one, maybe. We'll see. So, ooh, what happened? Uh, we have something. Not that. We have a greeting was hello Android, and then hello there with a black divider. So there you go. You have a column, basically a linear layout in vertical style, and then two text views with a divider. Um, so yeah, and I only changed the default preview here, but I should also change that in this on create because this is what we'll actually see if we run and deploy on a device. Um, Now the last part of step 4 is compose and Kotlin. Compose functions can be called like any other Kotlin function. This makes building UI really powerful. So I can use a for loop. Okay, so basically it says if we change this to take in a list of, then instead of doing this, we can just like loop through and just put in a greeting divider. And instead of passing that, we will just say name, and then we'll have a UI that loops through the name, the list, and there is hello there. And say if we want a different list, then we can override it in the content somewhere else. And we should see 3 rows now. Yeah, that is pretty cool. Try to do this in XML. I don't want to do that. So cool. So that's end of step 4. On to step 5. Now in UI programming, or in my day job at least, things are not this easy. We have state that we want to represent. So step 5 it is state in compose. So reacting to state changes at the very heart of compose. Compose app transforms data into UI by calling composable functions. Blah blah blah. Under the hood, use a custom Kotlin compiler plugin, and so when the underlying data change, the compiler or there are code to actually trigger like things like my screen content to be called again, and then like basically populate the UI again. So in order to, let's see, so for example, when you call greeting, Composable, you're hard coding the input Android. So we'll always see like Android there. Um, in order to add internal state to a composable, use the mutable state of function and gives a mutable memory. Let's see, to not have a different state for every recomposition, remember the mutable state using remember. Blah, blah, blah. Each copy will get its own copy of this, a version of the state. So if say in greetings, I guess, if we have an internal state that changes, say like the modifier for that particular instance, when we have multiple greetings, they will have different state, I suppose. So they want us to make a counter that keeps track of how many times the user has clicked the button. Define a counter as a composable function with a button. So I'm going to copy paste a composable counter. So now a lot more imports. Remember, mutable state and button. Not the widget button, but I suppose this one. So then we need to actually show the counter. So I suppose we want to add that in my screen content, and it says one more divider after the for loop and show the counter there. So let's refresh. And oh, there is a button now. That looks purplish. And let's look at the counter. So it keeps a count inside itself, and every time on click, it will like increment the count value, and the text rendered will be changed. So let's see, it is explained in the source of truth function. But before we go there, oh, so there are two ways to check here. So in here, we can say, show it in the emulator. Then it will actually launch emulator and show that on screen. Let me hide the build so the emulator is larger, and it should run soon. Come on. Come on, computer, you can do it. So here is just that view deployed, and we can interact in the emulator, and you see the buttons are, the button is like changing the state. Now there's a different way to interact with it, I believe. It should have something that is like an interactive preview button. Where is it? I actually don't know. Where is it? Refresh. Yeah, somehow I don't see the interactive preview button anymore. It should be like right here, and it should look like a finger with a circle on there. Um, but with that click, you should be able to actually interact with the button right in this UI. Somehow I don't see it. Maybe it will show up later, but let's continue. So the source of truth section in step 5 of the collab is basically telling us what is called a state hosting, hoisting. So it is going to basically pull out the state like the counter. So it will be passed into, say, the composable function, and we can have another state holding entity that is going to provide these states. Um, Making state hosting avoids duplicating states and introducing bugs. Yes, that is a big source of bugs in my day job. It is like because the state of each view is actually in multiple places. So synchronizing the source of truth to the UI is cumbersome and error prone. There are situations where the consumer might not care about a certain state. Uh, so in the example, it says like a scroller, then scrolling position is only of the interest of the scroller itself. It doesn't really matter in terms of the overall app state. In the example, since consumer counter can be interested in the state, you can defer it to caller by introducing count and update count pair. Okay, so let's do that. So the counter will now get count and update count uh, parameters. Count is an int. Update count is actually a function that passes an int into it. And then we can remove the count there. And also, we will just call update count with count plus 1. So again, update count is a function that we pass in. The function takes an int as a parameter and returns null. And so we'll just say, instead of count.value, we'll just say count. So before count was a remembered variable, but now it is, or before count was a remembered mutable state. Now it is just an int, and the text will just render the count. But then the responsibility of actually remembering the count value is now back in the caller. So now when we call it, we'll have to say count equals to something and say, let's remember the count here in my screen content. Counter state equals remember mutable state of an int. Then we'll say counter state dot value, and then we'll also want to create a function that will be updating the state, and we'll define the receiver as new count. Then we'll update this counter state equals to new count. So this way, if we run it again, it should still provide the same functionality. How do I actually get the interactive thingy? Do I need to remove the name here? Nope. So, okay, we'll just deploy on the emulator and see if it still works the same. But notice the difference between before and after. So before, the count was like controlled in this counter. Now it's actually controlled by my screen content. Let's see. Okay, it's still working. So we didn't break anything. And now the counter composable doesn't care and doesn't hold its internal state anymore. It is the screen that is holding that state. So that is something called state hoisting. So basically pull out your state to an outer layer. And I think that will actually be used later as well. Next up, we are at step 6 of the Collab, flexible layouts. So here, we briefly touched this column. It is used a lot according to other videos I watched about Jetpack Compose. And some of the speakers were saying this is as good as like this is good to a point that they were debating if they actually need to port coordinate layout over, but they still have to. Anyway, column is like the linear layout in vertical orientation. Now they want to introduce row as well. Row and column place the items one after another, and then you can change the weight modifier. Oh, so weight on the linear layout is still there. So anyway, say you want to put the button at the bottom of the screen while the other content remains at the top, blah, blah, blah. So let's see. We want to have a column with modifier equals to modifier dot the field max height. Okay, max height, and no more parameters. And then one more column is with modifier weight of 1. So it takes a float, so I have to put f after 1. And let's move the for loop into that column. And we can remove the divider because the counter is in a different column now. Okay, let's see, how does it look? Ooh, something changed. There is, so this outer column now actually fills the entire height of whatever preview is. And then this column now occupies just that part. And then, actually, no. So this column actually takes up the entire space until this counter is there. I think that's how it works. So you use the fill max. Okay. So another example of leveraging Kotlin in Compose, you could change button's background depending on the number of times it's tapped. That's a jump from the counter. Okay. So we'll say in the button, in my counter here, there is on click, but we also want to say change the color. So equals to button defaults, button colors. Wow, what did that? That doesn't feel right. Background color equals if count 5. Okay, let me try to format this better. So basically, it is saying like when you get a count, update the background color. Okay. Oh, it is white now. And if we click 5 times, on the 6th times, it actually turns green. So that is updating color based on some condition. Cool. Now let's make the name list more realistic. So far you have displayed 2 items. Before changing the items, actually extract the name column into dedicated composable. Okay, so it wants us to basically introduce this thing called a name list. Name list, and it takes in a list, and then remember, in in the convention for compose, modifier will be the last parameter to pass in. So that way you can chain the modifiers down the road. But let's call this in something. So we want to change the default list here into something else. We want to change it to a list of 1000 thingy. Was so then we should call name list in this column. But in order to like not blow up your memory, in the old world we use recycler view to basically like reuse the views for certain list of items. In the compose world, it is called lazy column. So we want to change name list to lazy column before we actually use that lazy column import. And then in the items, we'll change it to, let's see, item equals to names. And then the receiver will be called name. So that way greetings will be okay. And that should be good. And we can now call this as a name list with names and no modifiers. I think. Let's see. See if it builds. If not, I'll take a look at the solution and oh, there. But our buttons is gone. Is it because it's now at the bottom of that 1000 list? That's a lot of things to scroll through. Nope. So I lost my counter button. Why? Oh, because those two modifier dot weight 1f, I think. Come on. Yes, my button is back. So yeah, when I changed the column, I forgot to pass in the same modifier, so the button was lost. But now it's back. Cool. We can move on to the next step, I think. Yes. Oh, they have the full list of solution already down here. But anyway, I think my solution is pretty close. With one more new line here. Cool. I'll step to next section. Step 7 of the collab. Animating your list. With less than 100 lines of code so far, yes, I'm at line 94, you were able to display a long and performant scrolling list with a button that changes background. Sure. Say you want to change the background color of a list item you've clicked on. Hmm. Oh, and you actually want to animate an animated coloring. Animate color state API, but first update the greeting composable to add another state. Okay, so greetings will need to be changed. We want to change it to copy paste. Is selected a remembered view state and then a background color. So why is it? Oh, because we had imported mutable state of int, but this wants a mutable state of Boolean. Or let's see, maybe I need to remove the import here. I don't know. Why is it just not happy? Oh, it probably shouldn't be a var, but let's see. Let's continue. So the text is this, and we want to import the background and clickable. So these are all like modifier chains that you can just apply onto each other, like you were specifying different XML properties in XML. So padding, background, clickable is more like the unclick, and you can actually do this here in code. So somehow it is not angry anymore. Cool. So we need to make sure the two imports are there. Get value, set value. Otherwise, yeah, that's what it was complaining. Okay. And they want us to see animate color as state. So when the state changed from transparent to red, there should be an animation or something like that. So now we can actually add that to this. So we want, so this line is specifying the background color, this one, to be the background color of this text view. So if we run this, where did that interactive button go? Such a mystery. So now I actually have to launch on my emulator, and is that animated? Very subtle, but it is animated. So if I take out the animated composable here, then I might be able to say, so instead of doing this, I just say background color equals to if is. If I do this and just run, I think the animation, well, what? Okay, still failed. Now I have to actually rebuild the whole thing and then see the preview change and then deploy. So what I changed is the background color modifier. So now there's no animation. You can't really tell from the video, but the state change is immediate. Before my change, the state change is a bit more subtle. And I lost track of where I am in the code here. So let's run again. Updating, and my emulator should show up. So it is like slightly slower in like the appearance of that red background. Cool. So that is section 7, animating your list. Next up, theming your app. So far, all the color, background, and things like that are defined right here in the code. So we'll just say there should be a themes.kt, and here is the theme. Well, in the tutorial, it says basics Collab theme, but because I changed the name, so it's now StudyJam 3 theme. It is based on material, hopefully here, material theme, and it uses it changes color based on like light or dark, and then it also have a content that is material, because this is how we specify that my app and all the container of my screen, right? So my app, where's my app? My app is using a StudyJam 3 theme, which is just a material theme with the content. And so content composable is what is passed in here as with a surface of yellow in the content. Now, because the Collab theme wraps material internally and things will be themed, that's true. So it is basically saying here, we used to be, in the original UI, it was just a greeting. And then we can retrieve properties of material theme and use them to define the style of text in this way. So let me find a greeting, and we changed a lot of it. I'm just going to copy paste it here. So before, greetings was just a text, but now greetings actually can have a style that is from the material theme, because it will be wrapped in a theme that extends material theme. When you want to query a color or text style from your theme, use colors or typography. So we can also say, for example, background can't. I thought we can. Oh, so that's a modifier here, I guess. Background should be dot colors dot something primary. Then that's how you can specify a color from the material theme. Yeah. So if you see a preview, okay. So here, instead of that, we can say StudyJam 3 theme, then greetings to. Okay, if I refresh, it should show white and, well, not white, but some other color primary color and like H1 font. So that's a theming. That's how you use theming. Next is create your own app theme. Cool. So in the theme.kt, as you saw in the theming your app section, the theme is a composable. So we want to create a container. So we want to say another theme. Okay. And then again, it is getting dark theme from its system dark, and then it also wants it also expects a content there. So we're going to basically just copy paste some things. What is purple 200? Don't know. And copy paste. So dark colors, light colors, these are all resolved. Why? We need to define something, I suppose.
In mine, they're capitalized and they all come up. So I wonder.
Oh, you mean
well,
these?
I don't know. Am I looking at the right thing? Yeah.
Yes,
yeah.
you're correct. Thank
Okay.
you.
Sure.
So yeah, so if we like take a peek at the oops, I'm revealing way too much on my file system. So if we take a look at the basic Collab in a new window, you won't see it, but yes, you're correct. These should be all capitalized. So if we do this, and then instead of using StudyJam 3, we come back here and change my app to use Basics Collab theme. Then let me get this back and see if it changes how it looks. Okay, it didn't because I specify all the colors in here, right? So if I remove that surface, maybe it will actually honor my style. Maybe. Let's see. So my screen content doesn't really have any styles for it. So, and then greetings is using these. So if I want to use that, I'll need to basically say something like this in the text. So I'll copy paste this over. So instead of no styles, I'll pass in this style. So then if I rerun this, it should show something. Well, yeah, because of it of a header style. So again, we're at the end of step 8. And next step is congratulations. So we're done with the basic Jetpack Compose collab.